Welcome. In this video here, we will determine if this infinite series converges or diverges. In order to do so, we'll use the comparison test. So let's begin with a fact. And a fact is for all n greater than or equal to 1, 3 to the n plus 1 is always going to be larger than just 3 to the n. Pause the video and take a moment and just try a few values of n and prove to yourself, that is, prove to yourself informally that this inequality does hold. All right, now that you've paused the video, let's continue. That is, let's find the reciprocal of both sides. That is 1 over 3 to the n plus 1 is the reciprocal of the left, and 1 over 3 to the n is the reciprocal on the right. And since we found the reciprocal, that is, we flipped these fractions upside down. These were 1 before. We also have to flip this inequality so it faces the other direction. So I have now found some function. I found some a sub n, this one here, 1 over 3 to the n, that is always larger than this one here. How does this help us? Well, let's consider the infinite series from n equals 1 to infinity of 1 over 3 to the n, which can be rewritten as the sum from n equals 1 to infinity of 1 over 3 to the nth power. This is a geometric series. Furthermore, r is equal to 1/3, which is less than 1, so this series converges. Since this inequality holds, and we know that 1 over 3 to the n plus 1 is always smaller than 1 over 3 to the n, and this series here converges, by the direct comparison test, I can say that this series here converges. I hope you found this video helpful.